God morgen. Så er klokken blevet 10, og jeg vil gerne byde velkommen til det her webinar, som Wexøes Power Division holder omkring kabelbefæstigelse. Mit navn er Peter Hein Nielsen, og jeg er divisionschef for Power. I dag der laver vi lige inden vi hopper ind i selve emnet en kort opdatering på Wexøe, og hvad vi går og laver, og hvad status er i dag, og hvordan vi ser ud. Vi har jo skiftet navn fra Scope Case til Wexøe, og det fortjener nok lige et par ekstra ord. Og så kommer vi ind på selve indlægget omkring, hvem Ellis er, omkring cable fixings, standarder, specs og måder at teste på. Og så har vores kollega fra England, Phil, han har et par eksempler inden for den offshore vindsektor, og selvfølgelig også inden for elforsyning, hvad man bruger af produkter og løsninger her. Og så fortæller han også kort omkring de produkter, de har, og ongoing projekter. Dem vi har inviteret i dag, eller dem jeg har med mig i dag, det er Phil Goddard. Han er med fra England, og han er Ellis' Technical Development Manager, altså deres udviklingschef, og har en lang erfaring inden for det her kabelbefæstigelse, og har rigtig mange møder med den engelske elforsyning, men også mange andre internationale spillere, og også med den engelske bane og vindsektor. Så er jeg også med mig Sten Hansen, som mange af jer måske vil kende. Han er vores sælger, der kører rundt i Jylland og Fyn og besøger vores kunder der, og han er også produktchef på det her Ellis produktsortiment. Og så er der mig selv. Jeg vil tage introduktionen her, og så ellers overlade det tekniske til mine kollegaer. Ganske kort omkring Wexøe. Som nogle af jer måske ved, så er det et firma med 60 år på bagen. Det er privat ejet af Eliane Wexøe Mikkelsen. Der er i dag omkring 75 medarbejdere, små 80 medarbejdere, og vi har et hovedkontor i Værløse, de 25 minutter nord for København, hvor vi også har et mere end 3.000 kvadratmeter stort varehus eller et lager og en workshop, hvor vi kan lave mere kundetilrettede løsninger. Vi har også et kontor i Vejle, det er faktisk der vi sidder i dag sammen med Sten, min kollega. Og så har vi også her i 2018 åbnet et kontor i Lund i Sverige. Vi har nogle værdier. Det er meget med at have mod til at gøre tingene måske lidt anderledes, og vi vil også gerne have en profil af dyb indsigt i de løsninger, som vi tilbyder, og er også en dedikeret medarbejdergruppe, helt sikkert. Vi har 4 divisioner i dag i Wexøe. Tidligere havde Wexøe en del forskellige firmanavne under sig, hvor Scope Case var det, som Power er blevet til. Men der er også et industrisegment og et løsningssolutions, der laver datacentre, og så har vi man kan sige, den gamle kendte forretning for Wexøe, som er hele installationsforretningen. Det betyder, at vi er som sagt 4 divisioner, og installation af det mange kender Wexøe for. Det er alt inden for el og installationsmateriel, elektrisk installationsmateriel og bygningsautomation også. Der har vi divisionen Solutions, der tager sig af IT-infrastruktur og også kølesystemer primært til datacentre, hvis nogen har nogle udfordringer der. Og industribenet er relativt nyt, forstået på den måde, at vi er market making distributør for Rockwell Automation, der sælger Allen Bradley PLC-udstyr, automationsudstyr og komplementære løsninger, og det er altså også et ben, vi har i dag. Og endelig så Power-divisionen, som Sten og jeg repræsenterer, hvor vi leverer løsninger inden for elforsyning, vind og banen. Og lige et par ekstra ord omkring Power-divisionen. Som sagt, Scope Case skiftede navn her i februar til at være en del af fusioneret ind som en del af Wexøe, og er altså nu en Power-division. Der startede tilbage i 67, så har også en del erfaring med både elforsyning og vind også, men også banen. Og vi repræsenterer en del anerkendte leverandører her i Danmark, og Ellis er en af dem, vi har en eksklusiv aftale med på det danske marked. Vi laver cirka halvdelen af vores forretning er inden for elsektoren, altså inden for energi. Og så har vi 20-25% på banesegmentet. Selvfølgelig alt efter, hvor mange projekter, der lige er i pipen på banen. Så leverer vi omkring 20-25 inden for industrien, hvor vi også har renewables med, og vind er også den del. Og så sælger vi også noget igennem andre generelle installatører, entreprenører og grossister. Så det er den type forretning, som vi har i Power. Jeg synes lige, jeg vil vise et par af de kunder, vi har inden for elforsyningen. Der er jeg sikker på, at der er mange, der kender dem, og Energinet er selvfølgelig en vigtig spiller, når vi taler det store, tunge udstyr, som vi også leverer, men ellers så leverer vi stort set til hele den danske elforsyning. Og hvis vi lige tager et lille kig på vindsektoren, jamen så har vi faktisk også fat i de fleste af de virkelig store spillere, både der laver ting her i Danmark, men også internationalt. Så vi har ret godt fast i både elforsyning og vindsektoren. Jeg synes egentlig, at det var rigeligt omkring Wexøe, så jeg vil give ordet videre til Sten, der vil sætte et par ord på.
Ja, god formiddag. Mit navn det er som sagt Sten Hansen. Jeg er salgsingeniør her i Wexøe.
Okay. Undskyld. Jamen, som sagt, jeg er salgsingeniør i Wexøe Power, og hvorfor dagens emne er relevant i dag, det er, at efter vores mening har man for lidt fokus på, hvad det hedder, sikring af kabler. Når vi ligesom sammenligner med vores nabolande, jamen, så har man meget mere fokus på det, den korrekte sikring af kabler. Og det er selvfølgelig noget, som ligesom er opmærksom på, hvad det hedder, og prøver ligesom på at forbedre. Det vi skal være opmærksom på, det er de kræfter, der bliver frigivet i tilfælde af en kortslutning. Men også hvad det her, den måde, som ligesom kablerne bliver oplagt på, for afstand, der er med til at generere de her kræfter af kablerne imellem. Ellis, det er hvad det hedder, verdensførende inden for det her, hvad det hedder, kabelbefæstigelse, og gør sig rigtig meget i udvikling af de her løsninger, de nu har, og tester alle deres produkter. Kan vi lære noget af vores kollegaer i England? Ja, det må man sige. Hvad det hedder. Når man så sammenligner med os med England, jamen, så hvad det hedder, har de meget mere fokus på kabelbefæstigelse i England. Og jeg er sikker på, at vores kollega Phil herovre fra England, han vil komme ind på nogle af dem. Har man spørgsmål, så er man velkommen til at bruge chatten, der ligger nede i venstre side af skærmen. Og så efterfølgende er der en mulighed for at stille uddybende spørgsmål. Jamen, hvem er Ellis Patents? Ellis Patents, det er en engelsk kabelbefæstigelsesproducent, tilbyder hvad det hedder, specifikke løsninger til vind, elforsyning og banen. Løsninger de er designet med henblik på sikring af kablerne i tilfælde af en kortslutning. Og de hvad det hedder, alle produkter er selvfølgelig testet i henhold til den her IEC-norm, som er anført. Ellis de leverer løsninger til offshore vindprojekter og elforsyning, og arbejder i tæt samarbejde med blandt andet National Grid, Distribution Network Operators, DNOS, over hele verden, samt mange andre europæiske vindmølleproducenter. Ellis det er grundlagt i 1962 af Arthur Ellis og har hovedsæde i Northern Yorkshire i England, i en by, der hedder Rillington. De har cirka 55 medarbejdere. Og så vil jeg overlade ordet til Phil. Are you there?
Yes, I am indeed, yep.
Yeah, you are welcome to take over now.
Thank you very much, Dean. Good morning, everybody, and thank you for the introduction. I shall get straight on with the presentation. An overview of cable fixings in the wind and utility sectors. This is a sort of a rough agenda, a brief agenda of what I'm going to And anything else that you do need to know beyond my presentation is available on the Ellis Patents website, including data sheets and various materials relating to our products. Of course, it's quite comprehensive, so hopefully everything should be there for you. Okay, cable fixings. For those of you who are not familiar with cable cleats, this is what a typical cable cleat would look like. It's a small component. It doesn't have any moving parts. It has no electronics, so it doesn't look as though it's very exciting. And when things go well and things operate normally, they just sit there and do their job. But when things go wrong, in the event of a short-circuit fault, for example, these devices come into their own and they act as a safety critical component. So it has a very big responsibility for a small component. These are types of cable fixings. These are not international definitions. This is my own view. I'll bring them all up at once and just explain the differences between these different types of fixings. So the cleat I've just mentioned, the cleat has a great deal of strength in the lateral direction. So its main purpose is really to protect cables, protect surrounding equipment in the event of a short circuit fault. A clamp is much stronger in the axial direction, and as the name suggests, it clamps cables. So you can imagine if you've got terminations of cables, or you've got cables that are going up very high vertical runs, where you have to actually clamp the self weight of the cable. So these are very strong in the axial and also the lateral direction. A strap is essentially a cleat which doesn't fix onto a structure. So it's a floating device that just basically retains the cables in their formation. A hanger speaks for itself, hopefully. The cables aren't necessarily fixed to a hanger. They just, as the word suggests, they just hang on the saddles or on the hooks or the structures that are on the hanger device itself. In this particular example, there's 1, 2, 3, 4 different ways of attaching different sized cables to that particular hanger. And the last one is what we call a saddle. It's a much more high-end product. This is a forged and pressed aluminium from an extrusion. It's concave with a slight sort of bend in it so that it actually allows for natural sags of cables. And these generally apply to sort of large transmission distribution size cables up to 400 kilovolts. As I say, not international definitions. This is just how we define them. Okay, I'm going to talk a little bit now about standards, specification and testing, which as a cleat designer and manufacturer is very important. These are a few statements that are taken from BS 7671, the 17th edition of the IET wiring regulations. The new edition comes into force early next year, and the statements I've highlighted there, that every conductor or a cable shall have the strength and shall be installed to withstand electromagnetic forces, and that includes any current, such as the fault current. It also states that cables must be installed to hold their own weight, and that cables must be installed to protect joints and terminations. So those three statements together make it quite clear, hopefully, that cables need to be installed and fixed properly, and you need to do that according to a standard. Cable cleats, this is the standard, the international standard that relates specifically to cable cleats. It's IEC 61914. The latest version is the 2015 edition, and that should come into force about now. I think it's the end of this year, that any cleats that you procure really need to be up to the 2015 standard. It's a relatively new standard in the industry. There wasn't one existing before 2003, so this is quite new. Okay, I'm going to talk about specification. So that's largely what my role is really about, is making sure that we can get specified properly into projects at a very early stage. Specification is important because quite often, cable cleats being quite low in the supply chain, they're not always looked at with the scrutiny and the importance that they sometimes deserve. So these are the three items that relate specifically to the standard. So cable diameter sounds very simple and straightforward, but you'd be surprised how many times people procure cleats that aren't the right size for the cables, or they don't know what size cable is coming to the site, and that causes problems. Cable arrangement is whether you've got a single cable, whether you've got cables of 3 phases in a trefoil arrangement, whether they're bunched together or quads. So knowing how many cables in what formation is very important. And also from an electrical CMS point of view, the fault level. It's very important that we know what the fault level is, either the RMS fault level or the peak fault level, so that we can judge what strength of cleat is necessary for your particular situation. Other important information that we would like to have is knowing the structure. What are these cable fixings going to be fixed to? Is it going to be a simple containment such as a ladder, a tray or a wire basket? Will the fixings go directly into a concrete wall or into brickwork? So that allows us to choose the correct sort of fixing application depending on what structure, and also the size of the bolts, the type of the bolts, whether they're going into strut, whether you've got twist foot connections, all of that helps as well. And the last point I've put here so far is rigid or flexible. By that I mean, are the cables allowed to move? Will they naturally move according to the load variation during the day? 99.9% of the time there will be flexibility in the movement of the cables. It's very, very rare that you'll get an absolutely rigid cable system. So there's always some allowance for a little bit of movement in sag or snaking, as we call it. So that's really all about electrical and structure. And on the other side of the slide there, I've put the word environment. So where this cable arrangement is going to be situated, it's very important to determine what the environment is going to be like. Is it going to be in a dark tunnel with no sunlight? Is it going to be on an offshore platform where you've got extreme corrosive conditions? Is fire integrity an important aspect of it if it's in a building? So making sure that any liners are made of low smoke and zero hazards. So these are all important issues as well. So if we can get as much information as on the slide there early on in the project, this will hopefully lead to very, very good specification and cause minimum problems when cables and when fixings arrive on site at the project. Okay, moving on. I could talk about the standards in a lot of detail, but it would take a long time. So what I've tried to do here is to show you how all these different areas of design and engineering come into the central standard there, 61914. I've mentioned very briefly ultraviolet, corrosion, I've mentioned offshore conditions, material selection and fire integrity. So here you can see I've written various internationals and BS type ISO standards and how all of these come into the design and the manufacture of a simple cable fixing. Corrosion. I think it's important to mention corrosion because we're both in countries where we've got large sort of coastlines and large marine environments. So what I've got here is just a simple rusting process. So iron 2 being converted to iron 3 in the presence of oxygen and water. What I would like to show you is what can happen to cable structures, cable management structures. You can see here some outdoor situations. I think the top one there is a petrochemical complex, and you've also got some close-ups of the structures. Now, what's happened here is that they're in a marine environment or a heavily corrosive environment, and the structures themselves have started to rust. Now, that's quite often the case that they haven't been galvanized to a sufficient level, or the fact that the conditions were so extreme and they haven't chosen stainless steel maybe, and they've gone for a cheaper option. But corrosion in offshore marine environments is a very, very serious matter. We're talking offshore wind farms, so that's a very relevant statement there. There's also another sort of corrosion which is caused by having two different types of metal very close to each other in contact. From a chemistry point of view, we talk about what's called the electrochemical series or the galvanic series. And this is whereby if you have metals here on the right-hand table here, if those particular metals are very close to each other in that series, and they're in the presence of an electrolyte, which simply can just be water, with salts in, that allows for direct corrosion to take place under a galvanic sort of method. So it's important to make sure that if you're having metals that have to be those selections, for example, you have to insulate between them with a nylon washer or some form of insulation to stop them being in contact with each other. If you've got metals that are a long way apart on the series, such as closer together, if they're close together, then you're likely to get less impact. But if they're a long way away, you're going to get a much more aggressive impact of the corrosion. So depending on where they are, you have to be careful in the selection. Say, for example, aluminium ladder, stainless steel cleats. You're going to need some sort of protection there because you've got aluminium here and you've got stainless steel down here. So there's a large difference between the two. I think I've got, yeah, we're coming on to short circuit testing now. So I've got some video clips to show you, and hopefully it'll start getting a little bit more exciting for you here. So you see some explosions and things. So short circuit testing, very important to make sure that the cleats and the cable fixings have the strength that they're designed to have. What is a short circuit? In very simple terms, it's when a current flows through a path that is not intended in the design. It will flow to the point of lowest potential, usually a ground or an earth. And why do these faults occur? Lots of different reasons, and again, unfortunately, the most common reason is human error. Human error, basically somebody making a trench or digging where they're not supposed to, or somebody being given a drawing where the drawing is incorrect. Other conditions that cause short circuit faults are weather conditions, partial discharge, deterioration of polymers in XLPE type cables. Sometimes it's down to poor workmanship or poor quality. So there's 4 or 5 or maybe 6 main reasons, but unfortunately data shows that the biggest reason for short circuit incidents is human error. That's just it's just the nature of humans. Okay, I think I've got a few pictures here of some actual cable faults. It's very difficult to get good information on cable faults because cable companies don't like to supply them, and network operators don't like to talk about it because it's bad publicity, really. The top 2 here are, one of these is partial discharge deterioration between the conductor and the sheath over time, and there's ways of monitoring against that and trying to work out when it's likely to become an issue for you. There's lots of instrumentation methods to counter against that. The top right one is an example of very poor quality workmanship. This was a cable on an underground train system that's exploded, and you can see it was actually a steel wire armored cable. But essentially, these cleats have allowed that cable to remain in position without causing too much damage to surrounding equipment. The bottom 2 are examples of human error. This one on the right is a simple single phase to neutral error where somebody looks like they've gone of power station generation as well. So there's a very large range of project types under the classification of general utilities. And where do we use cleats in these applications? It's very, very widespread. There's dozens and dozens of different applications, and I've just listed a few of the larger ones here. So general site needs for power distribution from an LV distribution board and transformers. Power tunnels, which are a very specific focus. This is where you're using the larger saddles, using natural sag, quite often in purpose-built tunnels, and usually in areas of large infrastructure and urban sites such as London, such as Berlin. These towns have got large power tunnels, and it's becoming an ever more popular requirement, really, to take cabling underground. HVDC, where you've got interconnectors and links, quite often subsea, a large application there. And as I say, connections, substation work, wherever there's a new generation plant or a renewables plant, such as a solar farm or an onshore wind farm, there's always a requirement for connections and substation work, and therefore cable cleating and cable fixing. I'm going to talk briefly now about some products and some projects. Now, we've got a very great range of products here at Ellis Patents that will provide plenty of opportunity for both wind and for general utilities. This is not exhaustive, there's far more than this, but these are probably the more popular ones. Emperor is a very well-known product of ours, and Vulcan. So these are the very strong products in the lateral direction. So these will hold currents against very, very high levels of short-circuit force. Alpha, this is a sort of a formed extruded aluminium product in trefoil. These two are available in single cable applications as well. This particular product here, the cable guide clamp, was developed specifically for the offshore wind industry, actually. It was the Hellwin 1 project offshore Germany, and this was used on an HVDC converter platform where the spaces required were very, very tight. Very, very tight bending radiuses for cables. So a device was required, and Siemens was the operator here, the developer operator, and they wanted a device where they could pull the cable and clamp it in position using the same piece of equipment, and that worked very, very well, actually. So this is now a catalogue item and is working successfully. These two here, again, very, very widely used in the utility sector. So a typical aluminium two-hole clamp and a typical polymer nylon reinforced two-hole clamp there. Just a little bit of detail about those particular products. Emperor, we sell an awful lot of these every year. A very, very high lateral or loop strength. It's made of a corrosion-resistant grade stainless steel, 316 low carbon. It has a side closure, so therefore the overall height is quite low profile. Obviously compliant to the 61914 latest standard version, and also comes or can be supplied with a low smoke, zero halogen liner protecting the edges and the sheaths of the cable in case of a fault situation. And again, a very large range of sizes, from down to 18 millimeters right up to about 170, I think, on that one. Similar for Vulcan, it's a very similar product, except it has a top fixing. The loop strength of this is again high, but not quite as high as for Emperor. Again, compliant to these latest standards. They've all been tested in the last year or so, because we've had to bring our requirements up to the latest standard, and again available in a large range of sizes and with a low smoke and zero halogen polymer liners. Alpha, an extruded and formed trefoil aluminium cleat, 6000 series aluminium, so again it has a reasonably high level of corrosion resistance. They can be further powder coated, epoxy resin or powder coated, to give further protection. Top closure, and again we can provide a base that's either aluminium or in a polymer, so that comes into its own. If you're fixing that onto a stainless steel ladder, you'd want to separate that particular cleat from the structure using a non-metallic fixing, such as a polymer. This is the cable guide clamp. I mentioned this one. Very, very low friction material polymer there. It allows pulling of cables without the need to bring a lot of extra rollers and pulling equipment onto site, particularly when you're offshore on a wind farm, for example. As I say, it's available in a reasonable range of sizes. And again, we don't sell thousands of these every year because it's quite specific, but when you've got a particular problem, this comes into its own and works extremely well. Now, this is a specific product really used on the utility side. I mentioned power tunnels. This is the sagged, to allow natural cable sag, usually at fixing points of 7 or 8 meters apart. Very, very high lateral strength on this, available in 3 different lengths. And also, this shows you a single cable centaur, but it's actually available as a trefoil as well. So for large power tunnels or large power distribution requirements, this is a very, very versatile and specific product that's been used very, very great deal by the likes of National Grid and transmission operators overseas also. And again, just to show you a little bit more detail there, simple 2-hole fixings, UV stabilized option in the polymer, and a marine grade resistant corrosion in the aluminium one. Single cable formation, very, very popular product. Just to show you that Hellwind project there, the Hellwind 1, I've got the offshore platform there. Difficult cable pulling geometry, and as I say, you can show some of the techniques there that we've gone through to develop this product. We did an awful lot of computer modeling, finite element analysis to show the stresses and strains and to ensure that the polymer grade used was a very, very low friction. Tested live in front of Siemens and worked first time, so very, very pleased with that one. I've got a little animation here, and again, I'm only 50% confident that this is going to work. Oh, fantastic. Let's have a little bit of a video here. I don't know whether you can hear music at your end, but there is some background music as well, which I can't hear at my end. Okay, I hope that was visible to you. Okay, apologies that there wasn't any background music, but at least we were able to see the animation there. Just to show you that we have actually completed some fairly hefty, large-scale offshore wind projects, and I'll tell you which particular products were used. We've got Rampion there on the south coast of the UK, an Eon project, 400 megawatts, commissioned this year, using the Vestas 3.5 megawatt turbine. The products used on that particular project were Emperor and Vulcan. We have the Walney extension, a bigger project, an Ørsted project, which you're probably familiar with. Commissioning next year, fully commissioning next year. The Alpha, the aluminium Alpha is being used on that one, and that's with a combination of the Siemens and the Vestas turbines. And the London Array, which goes back 4 or 5 years now, another Ørsted project in collaboration with E.ON. That's the Siemens turbine, and I'm not entirely sure which product was used on that one, but I would guess it was Emperor. And just to show you the scale of some of the projects that we do have coming up in the UK offshore, I was at a presentation given by Equinor and Scottish and Southern last month about this particular project. It's the Dogger Bank. It's about 125 to 250, 260 kilometres offshore northeast of the UK. So that's not too far from where our offices are actually. We're just on the very edge of this map here. It's 4 1200 megawatt blocks that have been given licenses to develop. 2 of them are being developed by the Equinor SSE, and another one is actually being developed by Innogy, another 1200 megawatt block, and that's called the Sophia Wind Project. And each of these are very, very significant. And I think some of the turbine sizes are going up to 9.5 megawatts on these. So enormous potential for cable fixings on those. Just to show you an interesting utilities project, this is the Weir Bridge in Sunderland, again in the northeast of the UK. This is using a standard product, a polymer one-hole clamp, but bunched together in an array of the largest size. And this is for a 66 kV distribution cable to be strung underneath a new build bridge. It was a much cheaper option to put it under the bridge than to actually drill under the river. And this was a solution that went down very well with Balfour Beatty and the DNO operator, and saved an awful lot of money. But it just shows you the versatility that our products don't always have to be used directly for cable fixings. They were used for actually duct fixing. So those are ducts which the cables will actually travel through. So just a nice different example of some of our products being used there. And I think this is the last one of an actual project example. This is the London Power Tunnel, so this is one of those purpose-built 400 kilovolt up to 400 kilovolt ring mains, if you like. It runs for about 23, 24 kilometres around central London. And there's 2 circuits there, 1 circuit on each side, and you can see here this one hasn't been pulled in yet. So that's a Centaur saddle waiting for the cable to be pulled through. It has been completed now, but you can see here these are 7.4 metres between the fixing points. And you can see the natural sag of the cable there over the profile saddle, which allows for the variation in load during sort of night and day, if you like, on these large HV cables. Very nice project, that one, to be involved with. Oh no, sorry, I've got one more. Nuclear. I think Ellis has supplied products into just about all of them, the last 7 or 8 nuclear builds in the world, actually. So that includes Olkiluoto in Finland, Flamanville in France, the 2 China projects at Taishan, and also we're hoping to supply into the UK new build at Hinkley as well. I've had a meeting about that this week, and it's generally Emperor, Vulcan, and the Protect product, which is a cable strap, if you like. So we've done. We're very pleased with our record on nuclear power as well. Thank you for listening to me and my presentation today. I do apologise again that for some reason those little video clips, which is the most exciting part of my presentation, unfortunately didn't work today. But thank you for listening, and please do get in touch with me either directly or through Peter or Steen if you require any further information. Thank you, Peter. Thank you, Steen.
I need. Okay, we are having a little bit technical difficulties.
Can you hear me?
Just a second like that.
I can hear you. It's a little bit in and out, but I can just about hear you.
Can you hear me now, Phil?
I can hear you better now, yes.
Okay, super. Okay, then I will finish up. Jeg vil sige tak i dag for dem, der nu valgte at deltage i det her webseminar. Vi beklager selvfølgelig dem, at videoen ikke virker, og det kigger vi på. Og så vil vi selvfølgelig fremsende dem til dem, der har deltaget separat, så I kan se de her film her. Skulle I have spørgsmål til webinaret her, jamen I er velkommen til at skrive i den her chat her nu her, eller I er velkommen til at kontakte mig eller en af mine kollegaer, så vi hjælper, ikke? Tak for i dag, for dem der deltog.
Jamen, jeg synes lige, vi skal fortælle. Jeg synes lige, vi skal fortælle, at vi jo har leveret til både elforsyning og banen, og også til en del af de vindmølleprojekter til de store spillere her i Danmark. Som sagt er vi en eksklusiv forhandler af Ellis i Danmark.
Og vi bruger selvfølgelig en lang række af deres produkter, men det er helt klart, at Alpha og Emperor og de Trident cleats her, det er dem, vi ser den største efterspørgsel for her i Danmark. Så tag endelig fat i os, og I er også velkomne til at unmute jer selv lige nu her, hvis I har nogle spørgsmål, som I vil have Phil eller os til at svare på. Og ellers så er den sidste kontaktslide her, hvis I har brug for at kontakte os. Men jeg vil lige give jer lidt tid, hvis der er nogle spørgsmål, så endelig bryd ind og stille spørgsmålene til enten Phil eller os. Jeg tror ikke umiddelbart, der er nogle spørgsmål. Phil, it doesn't seem that there are any questions. Apparently they have understood all that you have been talking about. So
that's good news.
Yeah, it's very good news. And as Sten said, we will forward, of course, the videos which didn't play, a few of them, unfortunately, but we'll make sure that everybody gets the videos to see exactly how important it is to have the right protection and the right cleats for the job.
That would be great. Thank you for that. Yeah.
Sure. And other than that, thank you for your time, and have a good day. Ha' en god dag. Vi tales ved.
You too, guys. Thanks very much indeed for the opportunity. Appreciate that.
Thank you, Phil.